In the next three examples, I'm going to show you how to solve for potential energy. So in number 5, the problem says, what is the gravitational potential energy of a 60-kilogram student standing on the top floor of the Empire State Building, which is approximately 380 meters above ground? So in the problem, they give me the gravitational potential energy. Well, they're asking me to find that, which is measured in joules. But they give me 60 kilograms. So kilograms is the units of mass. And they tell me it's 380 meters above the ground. So that's my height, measured in meters. So what I'm going to do is just what I did with kinetic energy. I'm going to write down the equation that's on my equation sheet. PE equals mgh. So my potential energy is what they're asking me to find. My mass is 60. The acceleration due to gravity is a constant, which is on your equation sheet. It's 9.8. And my height is 380 meters. So they give me all of these variables. All of the variables are being multiplied by each other. So I'm just going to plug them into the calculator as shown. And it's going to give me 223,440 joules is my final answer. So if they give me mass and height, I'm just plugging everything in. I'm getting my potential energy. Okay, so in number 6, it's a little bit different. So for number 6, they give me some different variables. So number 6, a student of mass 45 kilograms, again, they're giving me the mass, currently has a potential energy of 5,400 joules. So they give me PE this time, and they tell me it's 4,500 joules. And they want me to find how far above the ground is the student. So how far is the distance? That is the height. That's my unknown that I'm looking for. So again, I'm going to write down my equation that's given on my equation sheet. PE equals mgh. My potential energy is 5,400 joules. My mass is 45. G is always 9.8 as long as we're on Earth. And I'm looking to solve for height, which is my unknown. So I'm going to keep my variable in there. So 45 times 9.8, these two are being multiplied by each other. So I can simplify that into my calculator. That gives me 441 H equals 5,400. So the 441 is being multiplied by H, so I can divide both sides by 441. Okay, those will cancel. And I'm left with H is equal to 5,400 divided by 441 is 12.2 meters is the height. So if I'm given mass and potential energy, I'm going to use these steps to solve for height. I want to do one more with you. So in problem 7, they give me a couple different variables. Maria is holding a ball from a height of 2 meters. So this time they give me height. It has a potential energy of 10 joules. That's PE. And they want me now to calculate the mass of the ball. So I'm going to write down my equation again for potential energy. PE equals mgh. I'm going to plug in everything I know. My potential energy is 10. My mass is my unknown, so I want to keep that variable in the problem because that's what I'm solving for. G is always 9.8, and my height is 2 meters. So I'm going to simplify as much as I can. 9.8 times 2, 19.6, m equals 10. The 19.6 is being multiplied by m, so I can divide both sides by 19.6. M is equal to 10 divided by 19.6 is 0.51 kilograms. So in this example, if I'm given height in PE, this is how I'm going to solve for mass.